Okay, problem number 12, another comet problem. Comet Enki has an elliptical orbit again, also with the sun at one focus. Enki ranges from 0.34 to 4.08 astronomical units from the sun. So let's picture this situation here. Here's the sun at a focus. Here's the comet going around. That looks really bad, so let's redraw that. Boom. There's the comet going around. It's going to have another focus over here. It's maybe not a special point like the sun, but it has a focus. And then we have some center there in the middle. And it says the comet Enki ranges from 0.34 to 4.08 astronomical units away from the sun. Well, if you think about its farthest distance from the sun, that's going to be this vertex right there. And then think about this distance right there, the shortest distance. That's going to be that little bugger right there. So we've got, boom, from the sun to that vertex is 0.34. And I can't write. I still can't write. There, that's 0.34. And from the sun to that other vertex, it's going to be 4.08. And so let's think now about what we know. This distance, right, let's go a different color. This distance right there from the center to the vertex is A, which means that this distance right there is C. The center to the focus is C. So that means that this distance right there from the sun to the vertex, aka that 0.34, that distance right there has to equal A minus C. I hope you see that. And then we can do a similar thing over here. We again know that distance right there is A, and we're going from the sun all the way over to that spot right there, which is going to be C plus A. And that distance we know is 4.08. So 4.08 equals A plus C. And let's go ahead and solve this little system. Let's just do it by hand. Let's add both equations together. So on the left, let's go 0.34 plus 4.08 is going to equal 4.42 equals A plus A is 2A, and negative C plus C is 0. So we get 2A is 4.42, and so we get A is 2.21, which is kind of a cool way to figure out that A value. Okay, well, if we know our A value, then we can figure out our C value. So let's use this equation. 0.34 equals 2.21, our A value, minus C. I lied. I'm going to be lazy, and I'm going to use what, in my opinion, is the easier equation. We're trying to solve for C, so let's just subtract that A over to get 4.08 minus A is 2.21 equals my C value, and let's crunch that. 4.08 minus 2.21 gives me 1.87 as my C value. And again, now I can say 2.21 squared equals, my A squared equals B squared plus my C squared, so 1.87 squared. So B squared is going to equal 2.21 squared minus 1.87 squared, which is 1.3872. And if we took the square root of that to find what the actual value of B was, we'd find that B is 1.178 roughly. Whereas, based off of the data, this B squared is a terminating decimal. So let's go ahead and write our equation just like the last one. The center is going to be at the origin, and the major axis is going to be on the x-axis. So we're going to do x squared over a squared, so 2.21 squared, plus y squared over b squared. And since I had to round that decimal for b, I'm going to actually use this form right here and just put 1.3872 right on the bottom there. And this is an ellipse, so equals 1